This is video 4 of 4 on solving equations with an x squared theorem. Now these examples are slightly different because they are in context. So we're going to look at an example using Pythagoras' theorem and an example using area. So example 7. Find the lengths of the sides in the triangle shown. So we can see here that we've got a right angle triangle and we've got lengths x plus 3 metres, x metres and 5 metres. Now, like I said, this is going to be an example using Pythagoras' theorem, and you would know that you had to use Pythagoras because you've got a right angle triangle here and you've got 3 lengths. Now you can see that 2 of those lengths are unknown at the moment. We've got x and we've got x plus 3. But actually, because Pythagoras' theorem is obviously an equation, we will be able to solve that and we'll then be able to get our value for x and therefore find the lengths of each of these sides. So for Pythagoras' theorem we need to remember where the hypotenuse is. So that is across from the right angle, opposite the right angle, which in this case is x plus 3. So that means we're going to have x plus 3 all squared is equal to x squared plus 5 squared. And that's the sum of the squares of the 2 shorter sides. Now, obviously in the left hand side here we have brackets, we have a square, so we need to expand that. So you can either use your area model, or remember we have looked at the quick method for expanding square brackets like this. So we get x squared plus 6x plus 9. So remember, we squared the first term, squared the second term, and then we multiplied the 2 terms together and doubled them to get the x term. So we've got x squared plus 6x plus 9 is equal to x squared plus 25. I notice that I've got an x squared on both sides of the equation, so I can subtract this from both sides, and that leaves me with 6x plus 9 equal to 25. Now the variable that I'm looking for is x obviously, and that's on the left hand side, but there's currently a 9 being added on to that. The inverse operation there is to subtract 9. So that leaves me with 6x equals 16. The x is currently being multiplied by 6, so I need to divide throughout by 6. On the left hand side that will leave me with x, and on the right hand side 16 over 6 will simplify to 8 over 3. So x is equal to 8 thirds. Now, you might think that we're finished this question because we've solved the equation for x, but actually the question has asked us to find the lengths of the sides. So that means all of the sides really. So we already know one of those sides, that's 5. We now know this side, x, so that was x metres, so that's now 8 thirds metres. And the x plus 3 metres, well that's the same as 8 thirds plus 3. So if we then just look at that, we can convert all of those to improper fractions. I suppose in this case, because we're dealing with lengths, we wouldn't, So we are dealing with lengths, so it probably is slightly unusual that we are using improper fractions at this stage. So we might want to convert these into mixed numbers. So our lengths would be 5, our 8 thirds is the same as 2 and 2 thirds, and our 8 thirds plus 3 is the same as 5 and 2 thirds. And all of those lengths are in metres, and those are our final answers there. Again, at this stage it would be a good idea to copy this down in your notes jotter. So example 8. Areas of the rectangle and the square shown are equal. find the value of x. So I'm dealing with area here. So remember, area is length times breadth, so that will help us when we go on a bit here. Now we're told that the areas of the rectangle and the square are equal. So we might want to set up an equation like this. Like I said, it's length times breadth. So the area of the rectangle is x minus 6 multiplied by x plus 6. And the area of the square is x minus 2 times x minus 2. So x minus 2 all squared. So for our left hand side, we can have our area model here. X squared, 6x, negative 6x and negative 36. And collecting terms there, we're left with x squared minus 36. So our x term is obviously eliminated because we've got a positive 6x and a negative 6x here. Now for the square, we get x minus 2 all squared. That'll give us x squared minus 4x altogether plus 4. Now at this point I might notice that there's an x squared term on both sides of the equation. That's positive, so if I subtract that from both sides, I will be left with negative 36 equals negative 4x plus 4. I could now subtract my 4 from both sides, and that would leave me with negative 40 being equal to negative 4x. I can now divide throughout by negative 4, and that leaves me with 10 being equal to x, but we normally write our equations, our final answers, with the variable on the left hand side, like so. So x here is equal to 10. Again, it would be a good idea to copy this down in your notes jotter.